Hello, thank you for checking out A1 Math, and today I am coming up with two videos here to get my students ready for the Chapter 12, Chapter 13 test. That's the Chapter 12, Chapter 13 practice test. So in this first video, we're going to talk about finding the distance, comparing lines that's parallel, perpendicular, finding congruent pieces on a congruent triangle, and a couple of rigid motion problems. So let's get started. So first I'm going to start off with number one here, where we're talking about finding out if lines are parallel to a particular equation. So they want to know between these four lines, which one is parallel to this one. And it could be more than one. All right, well, this is pretty simple. All you want to do is look at your equation where you have y is equal to mx plus b. And look at the spot right here, which is your slope. And you're going to compare those two. Or compare this to the equations to see which one's the same. If they're the same, then they're parallel. So our slope here is -2. And I want to look at each one and see which one has a -2 slope. Right? And this one, it's C, has a -2 slope, so C is the correct answer. Okay, and number two, we want to see which line or lines are perpendicular to y equal 1/2 x plus 3. So I've got 1/2 for my slope, and I want to find the opposite reciprocal, or one where the product equals -1. So if we have 1/2 for our slope, the opposite reciprocal would be when you do the reciprocal and change the sign. So I've got the reciprocal to 1/2 is 2/1, which is the same as 2. And I'm going to change the sign. Since this is positive, I need a negative. So again, I'm looking for everything that has a -2. All right, so I take a look at all my slopes. And the slopes with -2 is A and C. All right, now you want to be careful. This is the y-intercept. This is the b. You never want to go with b when you're comparing slopes, because it's not the slope. That's one thing you want to keep in mind. And the slope is always multiplied against x. So before I move on, I want to give a couple more examples of an opposite reciprocal. So for instance, let's say we had, and this is separate from the problem, but let's say you had 3/4. The opposite reciprocal to that would be -4/3. Let's say you had a -5. The opposite reciprocal of that would be a +1/5. You would put this over 1 and then flip your fraction and change the sign. So those are a couple examples of opposite reciprocals. And remember, you're looking for those when you're looking for perpendicular to your line. Okay, now, just keep that in mind. Now we'll take a look at finding the distance. And there's a distance formula, but I taught my students how to use the Pythagorean theorem to find the distance. Okay, so to find the distance, what you want to do is take your 2 points, draw a line, and make it a right triangle. And use the Pythagorean theorem, which is a squared plus b squared equals c squared. So your A and B are your legs to your right triangle, and C is your hypotenuse. We're looking for C, which is the distance from this point to this point. And let me zoom in here so you can see more. Okay, so I count this side, which is 2. 1, 2, and then count here. 1, 2, 3, 4, 5, 6. So my two sides are going to be 2 and 6. So I plug those two sides into the formula. Alright, and I square both of these here. I'll get 4 plus 36 is equal to C squared. I add both of these. And now to get C, I gotta do the opposite operation. So I'll do the square root on both sides and get 6.3 is equal to C. Remember, it says here to round to the nearest tenth. So that's how I get 6.3. All right. Now I'm gonna do another example here. Okay, now do the exact same thing. Make a right triangle. Skinny right triangle, but a right triangle. I have a 1 here, and this is 8 squares this way. So I'm gonna use 1 and 8 in my A squared plus B squared equals C squared. Okay, next I'm gonna go ahead and plug in these values here. And it doesn't matter which one you put for A or B, as long as you don't put it there for C, because it's not the hypotenuse. So you can put your 8 here and 1 here, it doesn't matter. So now, go ahead and have 8 squared equals C squared. 1 squared is 1. 8 squared is 64. Alright, and now add these two together. And take the square root. And I'll get 8.06 is equal to C. And with that 6, I'm gonna round it up to 8.1. Or close to 8.1. So remember, you wanna make a right triangle between your 2 points, or from your 2 points, count each side and plug them into the Pythagorean theorem. All right, let's take a look at number 5 here. All right, here it says complete each congruent statement by naming the corresponding angle or side. So what we have is 2 congruent triangles. And with the 2 congruent triangles, what we want to do is find the spot or find the congruent corresponding part that matches with the one that's given. So we see here they want us to find angle M, or find a congruent piece to match with angle M. So to do that, what you want to do, the best thing to do, is don't let the picture throw you off. You want to look at the actual congruent statement and match it up with the part for the other triangle. So here I have LMN, and I have my M in the middle. So the angle that's going to be congruent with M is going to be I. So the part that goes here is angle I. Okay, let's take a look at number 6. All right, this time, instead of looking for an angle, we're looking for a side. So here, got RS, that's what's given, and we want to match it up with the same thing over here. It's going to be RS. And you want to do that regardless of how it comes. Let me give you a couple more examples. Let's say you have, let's say we're trying to find a congruent statement to TS or TR. Or the congruent part that goes with TR here. Well, I would do the same thing. Here's T and R. So I would match that up with E and R. So that would be segment ER. All right, so that's a congruent statements there. Let's take a look at a couple rigid motion problems. Now, in this example, they want us to write the rule describing each transformation. So they don't tell you which transformations it is. We talked about 3, and it was all rigid motion. Translations, which is slide. Rotations, which is turn. And reflections, which is flip. So, what we want to do is figure out what happened here on this particular transformation. Well, keep in mind that you got to know what's the beginning polygon and what's the ending polygon, okay? Well, it's called a image and a pre-image. The pre-image is going to be the one without the marks. That's where you start. And the ending image here is right here with the marks. And you can tell that this has been flipped over. And not only has it been flipped over, but it's been flipped over the y-axis. So we would say this is a reflection over the y-axis. Okay, let's take a look at our last example for this video here. All right. So we want to figure out what type of transformation this is. And it looks like it's been slid coming down here and toward the left, because this is our pre-image and this is our image. So how far to the right, to the left has it been slid, and how far down? We could just find one point to get that indication. So here I'm gonna start with C, and you see that it goes down 2 units. So I'm gonna say it is a translation two units down. And let's see, if I come down to how far do I need to go to get to C here? So that's going to be 5. And then to the left, 5 units. Oh, and you can't see any of that, but you can now. So again, let me go back over that. We've got a translation, 2 units down, and then over 2 units to the right, 5 units to the left. Kind of butchered that one, but you get the drift. And for the test, they're going to be multiple choice. You just got to pick it. Okay, so that concludes this video here. I'm gonna go ahead and give part 2 to go over the rest of the practice test problems. And again, thank you for checking out A1 Math.